let R be the region bounded by y equals 8 root x equals 3.75, and the x-axis. R appears below. So it's this region right here. This is R, because this is the equation y equals 8 root x, and this is stopping at 3.75. And of course, here we have the x-axis. So there's our region, this region right here. Now we're going to find the volume by rotating that region about the line y equals -2. We're going to rotate that about the line y equals -2. So what's that going to look like? Well, let me come over here. And here I went ahead and graphed. I put in that's 8x, that's 8 root of x, right? X to the 0.5. And that's y equals 0. This line is y equals 0, right? It's the line that goes through the y-axis. It's the y-axis at a height of 0. That gives you the x-axis. And then I graphed it, okay? And I put it into the 3D thing, and we can take a look at it. So it's going to rotate about that line. So here's the line, y equals -2. So let me show you what it's going to look like. Let me be a little helpful here. So let me see, it's going to go to 15 to 17, something like that. So about right there. So it's going to go kind of like that. Oop, use my tool. Like that. And down, there we go. Nope, that's not correct. Having done that, that's not, here we go. That's a gap of 2, so that's going to go from right here. Oh, wrong color. So let me try that. So it's going to go, it's 2, that's 2. Oh, I don't want that straight. Okay, it thinks I'm making it straight. There we go. That's going to go right there. How do I know? Well, this is -2, right? We're rotating about -2. Careful, that's an S, not a 5. I made that mistake at first. This is y equals -2 on the y-axis here. So what? Well, that means this is a distance of 2, so this must be -4 because this is also a distance 2 away, right? It's going to rotate, so that must be -4. That's coming down here, and this part's going to go like that, right? And this part will be right here. So that's what it's going to look like, right? It's going to rotate. It's going to rotate, oops, about that line, y equals -2, that green line. It's going to rotate the whole shape over. It's going to produce, you can see the 3D image there. There's what it's going to produce, okay? And so now to find the volume, we got a bunch of washers. You can see them right here. There they are, washers. See that holes in the middle? So we got to do each washer. So let's do it. Each washer, the volume of each washer is pi capital R squared minus pi little r. Capital R is the outer radius, little r is the inner radius, times the thickness. Okay. So now the question is, what's the outer radius? What's the inner radius? Well, you can see it. Let me show it right here. So the outer radius is going to be here to there, right? That's capital R. That's from the center, right? Because this is the center now. It's the center rotation, right? You can see it on the 3D diagram as well, from here all the way to there. That's the outer radius, isn't it? And so what is that? Well, that's a little tricky. Let's think about that carefully. This right here is 2. Oh, by the way, that's the inner radius, huh? That's easy. That's the inner radius. Inner radius is 2. We can see that right here. This little inner radius. Inner radius is 2 all the time. It's always 2. So the inner radius is 2. Now, the outer radius, what's it going to be? Well, this is the curve y equals 8 square root of x, right? That's that blue curve right there. Y equals 8 square root of x. What's y? What is y now? Careful, careful. Y is the height from there to there. Let's write that right down here. That right there is y equals 8 square root of x. Why? Because y, x and y, think about, be clear what x and y mean on a graph or an equation. Y is from the axis up to the curve. So then what's capital R? It's going to be all of y plus 2. Do you see that? Let me do it. Colors, maybe they'll help you. Plus 2, because that's the little inner radius. In other words, capital R, from the middle all the way up to the curve is the y value from the origin up to the curve plus 2. Again, y values always start at the origin. That's how you graph, right? You start at the origin, you go over x, up y. When you get to this point, you'd go over x, whatever, you go up y from the origin. So then capital R, the outer radius, is going to be that y value from the axis plus 2. Y value plus 2. So we go, oh, okay. So then the capital R is the y value, which we know is 8 root x plus 2, because y is 8 root x, right? Just popped it in there. Y is 8 root x. So there we go. So the outer, and that's because we got to get everything in terms of x. You can see it's dx integral. So therefore, the outer radius, we got it now. This is going to be pi, and then the outer radius squared. What is the outer radius? It is 8 root x plus 2. Plus 2. Okay, minus pi times the inner radius. Inner radius, we saw that's just 2 all the time. And then the thickness is dx, right? What you can see the thickness just right here on this one. It's dx thick. It's how thick each disk is. You can see it right here as well. This is the x-axis. It's dx thick as we stack them up. All right, and then we're doing that integral. We're doing that integral from x equals what to x equals what? Because it's a dx integral. So we're stacking along the x-axis from here to here. How far is that? That's from here to here. So that's easy to see. That's x equals 0 to x equals 3.75. So 0 to 3.75. And there's our integral. 0 to 3.75. Put the pi outside. 8 root x plus 2 squared minus 2 squared dx. And so there we go. The tricky part is the outer radius, right? Which is from the line of rotation all the way to the curve. So that's the y value, because y values are always from the axis, add 2. And the inner radius is just 2. So there we go.